This is question 4 from the November 2018 Standard Level Mathematics E-assessment for MYP. And we've got an animation of two cars going around a track, so let's have a watch. So the blue car gets around the track in 6 minutes and the red car gets around the track in 8 minutes. So let's see what we have to do. So car X completes one lap in 6 minutes, car Y completes one lap in 8 minutes. Determine after how many minutes the two cars will meet at point A. So in order to do this, let's think of this in terms of after the first lap. We've got car X and car Y. So car X is the blue one. Car X completes it in 6 minutes. Car Y completes it in 8 minutes. So that's after the first lap. After the second lap, car X has driven for 12 minutes. Car Y has driven for 16 minutes. After lap 3, and what we're doing is we're trying to see when will these numbers be the same, when will they have the same multiple. So that will be 18 minutes after lap 3. Car Y will be 18 plus, that's 24. And after lap 4, car X, so 6 plus 18 is 24. And so car Y will finish lap 3 when car X finishes lap 4. So they are meeting at point A after 24 minutes. Okay, so just when Y is finishing lap 3 after 24 minutes, car X will be finishing lap 4 after 24 minutes, and they will both be back at the finish line. Okay, let's go on to part B. Okay, so we've got more interactive media. So it is just taking our track and representing it by the diagram. 6 semicircles with radius r and 2 straight line sections of length 4r. And I think if we just scroll on down, there we go. We're told, given the total length of the track is 15 kilometers, so it's 15 kilometers the whole way around, show that the radius of one semicircle is 560 meters to the nearest 10 meters. So just taking part B, put it in a separate page, make it easier to see. And we're told that the total length of this track is 15 kilometers. So let's see if we can write out the total length of the track in terms of r. So I've got 1, 2, 3, 4, 5, 6 semicircles. So if that is 6 semicircles, that is how many full circles? Well, that's going to be 3 full circles. And just to show, so it's half a circle, another half, so that's 1 full circle. I've also got half the circle plus this half circle, that's 2 full circles in total. And then I've got another circle right here, half and half. So that gives me 1, 2, 3 full circles. And I want to work out the distance around each of these circles. So the distance, let's do around 1 circle. So the distance around the circle is called the circumference, and I have got the formula for that in my formula booklet. Circumference is 2 pi r, where r is the radius. this is just for one circle at the minute, so imagine just the blue one. So C is equal to 2 times pi times r. And I don't know what r is. R is what I'm trying to figure out. So the distance around the 3 circles is going to be 3 times 2 times pi times r. And 3 times 2 is 6 times pi times r. So the distance around these circles that I've highlighted is 6 pi r. Now the total distance around the track is going to be the distance around the circles, 6 pi r, but I've also got 4r for this length and 4r for this length. So I've got plus 4r plus 4r, and we know that the total distance around the track is total length of the track is 15 kilometers. So I can let this equal 15 kilometers. So I've got 6 times pi times r plus 4r plus 4r is 8r. And I need to now solve this for r. So if I go to my calculator, and I'm going to put in 6 times pi so that's 18.8495, and I think yep, I'll round up then, and that's r, so we've got the r, and then we're going to add on 8r. This equals 15. So I want my answer plus 8. So it's 26.84956. And that's r is equal to 15. Now to get the r by itself, this 26.8 is multiplying by the r, so to get rid of it, I need to divide both sides by 26.84956. So when I do that, I put it into my calculator. I'm going to have 15. So I'm doing 15 divided by the 26. I'm just going to put that previous 6 times pi, and I want to add on the 8, sorry, so just do that one more time, 6 times pi plus 8. Okay, so I've got my 26.84956, and I just did that so I don't have to worry about rounding, because I can do my 15 divided by that previous answer, I get 0.55866. 0.55867, we'll round up. And this is in kilometers. Now there are how many meters in a kilometer? There's 1,000 meters is 1 kilometer. So in order to change this into meters, I'm going to need to multiply by 1,000. And again, if you want, you can do it on your calculator. But you shouldn't need, well, if you want to do it, make sure you don't make a silly mistake, then go for it. And 558.67. And that's now in meters. And we need to give it to the nearest 10 meters. Oops. So just pop this over here so we can see. So r is equal to, this is our tens column, and we looked at the units bigger than 5, so I'm going to round up. So it's 560 meters, which is what they gave us. Okay, hopefully that all makes sense. You just take your time, do all your working, and you will get there, okay? Okay, so for part C, we're told that the layout of the racetrack has inspired a company to create a logo in a similar shape. So this is the logo. Diagram 2 is an example of the use of the logo. Find the area of the logo when the radius is 5. So we're now looking at area. Okay, so part C. So yeah, we have to now work out the area of this logo when R is 5. Now there's different ways you can go about this. It looks a bit horrendous, but what we'll do is I'm going to split this up into different shapes that we can work out the area of easily. So my first one, I'll just go around all the first part. Okay, so I've created a rectangle, ADEH, and I can work out the area of that rectangle easy enough. So area of rectangle ADEH, and the area of any rectangle is length multiplied by width. Now I know that the width of this rectangle is 4r, 4 times r, and we're told that r is 5. So 4 times 5 is 20, so this distance is 20. Now, the length of this rectangle, so we're told that the radius is 5, so this part is 5, this is 5. Okay, same with this. This is all going to be, well, 5 and 5, so this is all 10. And the distance from here to here is also 10. So the total distance along, okay, imagine we've got 1, 2, 3, 4, 5, 6. 6 groups of the radius, which is 6 5s, which is 30. Okay, 10, 20, 30. So our area of this rectangle is 600. Now we also need to include, so if I just actually get my highlighter, I need to also now include the area of 1, 2, 3. Need to include that. But how many circles is that? That's 1 circle, 2 circles. But I do not want to include this part. Okay? So I've got 2 circles that I definitely need to include, but I don't want to include these parts because these parts are being chopped off. So I only need to work out the area of 1 circle. Now the area of a circle from our formula booklet is pi times r squared. And we know that the radius is 5, so if I put this into my calculator, pi multiplied by 5 squared is 78.5398. Okay, so hopefully this makes sense. Okay, I've done the area of the full square. Then I need to include the area of 1, 2 circles, but I do not want these circles. Okay, this full circle. So I've got the 2 circles that I need, subtract the 1 circle that I don't need. That's just 1 circle. So now I need to just, where's my pen? Area of the full rectangle, which is 600, and I'm adding on our 78.5398. This is our area of the logo, which is, you don't need a calculator, 678.54 millimeters squared. So this is the area of this full shape. Hopefully that kind of makes sense. Excuse my coloring in. Okay, we did the full rectangle, added on 2 circles, but we also need to get rid of these circles, this circle, and so that is only 1 circle that we need to add on. Hopefully that makes sense, okay? Let me know if it doesn't, if you need me to make any clarifications, and hopefully that's all okay.